Welcome to the Angular Fundamentals course with me, Todd Motto. In this course, you're going to learn all the fundamentals that you need to build Angular applications with. But before we get started, what we're actually going to do is look at the high-level architecture of an Angular application, so you get a high-level understanding of what an Angular app looks like before we actually dive into some code. The typical architecture of an Angular application is made up of these 5 building blocks. So we have modules, components, directives, routing, and services. So what we'll do is walk through each of these one by one just to give you a high-level overview before we actually dive into writing some code, so you get a better understanding of an Angular application architecture before we dive in. Now, a module is a main building block of an application, so we can have multiple modules, we can have a single module, we can have modules that depend on other modules. So think of a module as a building block that can contain specific components, like a feature component, a service that ties in with that particular feature, and some routes to tell it which URL to go to in our application, such as /inbox. Now, if we look at this diagram, we can imagine an email client. So on the left, we have our chat, which you might have your inbox chat. In the center, we have an inbox, and at the top, we have a search. Now, each of these could be a module. So we could have a search module, a chat module, and an inbox module. So inside these modules, you can have specific components that are related to chat, specific components related to search, and so forth. So what is a component? A component contains a template, it contains the data and the logic, and it also forms part of a DOM tree. So when we're writing HTML to begin with, we're actually creating a DOM tree whether we know it or not. Now, a component is a higher level DOM tree node, which will then create subtree nodes. So this diagram here basically represents what our DOM tree of components will look like. And each component can then render its own HTML inside, but we call this approach a component architecture, which we'll look at further on in this course to actually use Angular to the fullest. A directive is something that we can bind to an existing DOM element or an HTML element or a component, or just use it inside a template on its own, which will extend or transform a particular element and its children. So you can see here that we have our component tree, however, we have an extra red box. The red box is indicating that we have a directive bound to this particular component, and this could be any component in any particular module. So let's assume that this is a search box and we've added a directive to then tie in some particular behavior. When a user types, we might want to listen to an event. Angular also has a lot of built-in directives, so we'll be learning about these during the duration of this course. So a service is basically our data layer. All we've talked about so far are the particular components. Now, it's great having a component, but how do we actually get data into a component? So this is what we call a service. So if you imagine we want to make an AJAX request to our API, we want to fetch some data back, and then we pass it into a component. The component can then render that data, and we can make changes in the view, and we can update the back end, of which all of this logic will then lie in a service. So this is where we make things that are not component related, such as an API request, for example. Now you can see here in the next diagram, we also have in our component tree a service that we've assumed that is bound to a particular component. So this is giving you an idea of how a service can be tied to a particular component to give a specific component its data that it needs. Finally, we have routing. So all the routing is that it drives the navigation for our application. So it basically tells Angular which components to render based on the URL state. Now, if we head over to the next diagram, you can see that we have a purple component. Now, this is just a generic component. It's an ordinary component. However, we can assume at this point that we might want to change these two components that are child components based on the URL. So we might want to say, if we are at /inbox, we want to render the left-hand component. If we're at /settings, we're going to render the right-hand component. So this just signifies that this component can then have some kind of routing information bound to it, so we can render dynamic components. So now we've covered the Angular architecture at a higher level, let's get started with the project setup, installing the project, downloading the dependencies, and get writing some Angular code. In this lesson, all we're going to do is create a non-Angular specific piece of code to actually introduce you to TypeScript classes. Everything in this course will be written in TypeScript. Do not worry if you are unfamiliar with TypeScript, because TypeScript is actually fairly simple. So let's assume that we have a shopping list. So what we're going to do is create a function called shopping list. Inside of here, we might do this.groceries, and we can just initialize that to a simple array. Now, if we wanted to create an instance of this, we could do var mylist equals new shopping list. So this then treats the function shopping list as a constructor function, and inside the constructor we have an array of groceries. Now, if we wanted to add a public method to this actual shopping list object, we can use something called the prototype. So we're going to create a function called add item, and that is just also going to be a function. The item that we're going to add is going to be passed in via a function argument. So inside of here, what we can do is do this.groceries. So we're going to actually reference the array above, and all we're going to do is simply do this.groceries.concat. And all we're going to do in here is actually concatenate the item. So this is in fact an immutable way of doing it. If you're used to normal JavaScript, what you might actually do is something like push, and then you'll push the particular item into that piece of code. This is a way that we can do this immutably, which Angular actually favors because it makes change detection much easier. So when we start thinking about immutable objects and immutability, this is how we should typically do it with an immutable state. So let's go ahead and go down here and say my list, and we're going to add an item to our shopping list. So we'll just simply add a banana, and what we'll do is console log, and we'll do my list.groceries. So because the groceries is a property inside the constructor, all we're doing when we call add item is actually passing in the banana, and we're going to simply log this out, and we're going to check this out in the browser real quick. So in the console, we have a couple of logs. Some of them are actually hot module replacement, which is what is part of our Webpack setup to look at our changes. The part that's actually important is this array here. So you can see it's just an array with a banana inside. If we click on this, we can actually see that the console log is coming from our groceries. So let's go back and add another method to our shopping list. The next thing we can add to our shopping list is another prototype method, and this time we're going to call it remove item. So all we're going to do is simply remove it from an array. Now again, we're going to pass the item in, and this time we're going to do this.groceries, and then again we're going to use an immutable method. So we're going to do this.groceries, and then we're going to use .filter. So filter will actually iterate over the groceries, and here we'll get each individual grocery. Now inside of here, to be passed back to our initial groceries array, the actual grocery has to pass a specific test. So all we need to do is say return item does not equal the grocery. So all this is doing is simply iterating over the groceries. We're checking that the item that's passed in, which will be a string, is not equal to the current string. So this really is checking that banana does not equal banana. If it is, it will not return it to the groceries because filter actually returns a new array, and we'll just simply bind it here. We can clone this and change this to remove item. So we'll go down and we'll do another console log just to see this. What we'll actually do is clone this again and change this to apple. So we should see banana and then apple, and then in this groceries we should see both of them. Then we're going to call remove, and then we'll have a console log with the grocery list. So at the end we should just see the words apple in our final array. So we have our array. The first function call is adding the banana, the second one is adding the apple, then our third function call is actually calling the remove item. So we have the apple in this array. Banana has now disappeared because it did not match the return statement from the actual filter method that we just implemented. So what we're going to do now is go back to the code and actually rewrite this in what we call an ES6 class or an ES2015. And this is essentially what we'll be using throughout this project to create Angular components and services, So this is basically a refresher session if you're not used to TypeScript classes on how to actually write TypeScript classes. So underneath, what we'll do is create class and we'll call it shopping list 2. Now a class has just 2 opening brackets. It doesn't have a function call such as this. So all we do inside of here is specify a constructor. So inside of here, we can do this.groceries equals that array. Now you can see here that we have this.groceries with a red underline. So it says property groceries does not exist on type shopping list 2. So that actually means that we have to add a property, and you can see I'm not doing this.groceries. I'm actually just declaring the fact that I'm using something called groceries here. And all we need to do is say that it's going to be an array. Our groceries is a string and it's an array. So if you're not used to TypeScript, this is your first introduction to how to actually add types to specific things. This will help you improve and write better JavaScript. And all we're doing here is saying we have an array of strings. So this is basically telling TypeScript that it should pick up on any errors that we actually make. Now, instead of adding something to the prototype like we've done above with add item and remove item, all we need to do in a TypeScript class or an ES6 class, if you've already used them before, is just do this. So this is basically kind of like this. However, we don't use the function keyword. So this is just a public property on our shopping list 2 class. Now, again, what we want to do inside of here is pass the item in, and we're going to do this.groceries. And instead of doing this logic, which is this.groceries concat, we could absolutely do this. However, we have something in ES6, which TypeScript also supports, called the spread operator. So all we can do here is create a new array, and we can use ... So this will essentially pass this.groceries into this to create a new array with the groceries inside. However, because we're adding an item, we want to pass the item from the add item into the new array. So it's going to start off with basically merging this new array and adding the item. So each time we call add item, this piece of code gets run and we add the new item to the existing array, which may contain one or more objects. Now, the second thing we have is a remove item function, which also takes a function argument as the item. And all we'll do inside of here is this.groceries equals this.groceries. Now, again, we can use filter. And this is where we did function, and then we passed in the current grocery, and then inside this function call, we did our return statement. So we'll actually do this, and we'll do return item does not equal the current grocery. However, we're going to also learn about ES6 arrow functions. So this is a shorthand way that we can use a function without actually declaring the function keyword, and it automatically sets the this context. So inside of here, we can actually use this dot something. So let's assume we have this dot foo available. If we want to use an arrow function, we can essentially use the lexical this value via an arrow function by doing something like this. So if we needed to access a this property inside of here, we can then go ahead and use the arrow function. Now, there's a really nice feature with arrow functions, which is a shorthand syntax. So I can remove this semicolon. And you see this return statement, we can actually remove this. Now I'm going to put this on the next line, and this is something called an implicit return. So it's essentially passing in the current grocery, and because we're using an arrow function, we can use this shorthand syntax. So this underneath, all we're doing here is simply return item.grocery. However, when we use this shorthand syntax, we don't actually need to write the word return. It's automatically returned for us. So let's go ahead and create a const. We'll do const and then my new list, and we'll say new shopping list 2. So we're going to go ahead and create a new instance of this shopping list. We can then console log the new list. So above this, we obviously want to go and add some items. So what we'll do is my new list and then add item. This time we're going to add a pear. Then we're going to add a pizza. So inside of the console, we can then go ahead and do .groceries to actually get this array object, which we created here in the constructor. So the main difference between these is that the function in the shopping list acts as a constructor function. If we want to add internal properties, we can create these here. So we have this.groceries as the array. Prototype methods basically live on the actual TypeScript class, and this syntax is a lot cleaner to read. And that's essentially the main differences between the two of these. And all you need to know is essentially that JavaScript functions will now be using ES6 classes, which is what we'll be using throughout this Angular course. In this video, we're going to talk about imports and exports. Now, these are not specific to TypeScript. However, TypeScript is a superset of ES 2015 or ES6. So essentially, an import and an export allows us to import something from another file. Now, these somethings are called modules. A module can be a string, it could be an object, it could be an array, it could be a decorator, it could be absolutely anything that you want to export. So let's assume that we have a function inside of here, which simply makes something uppercase. In TypeScript, we will then say, we're going to take a string and it's going to be of type string. So this is already introducing you to TypeScript in a function argument. So normally in JavaScript, we would write something like this. However, in TypeScript, we say it's going to be a string. So TypeScript can then check that the value that we're actually passing in is in fact a string. Now, inside of here, what we could do is do return and then str, which is our function argument, and then we can call to uppercase. So this will essentially create a new string, which is then converted to uppercase. Inside of here, what we might do is let and then my name, and then we can simply do equals Todd. Now we can optionally type this and say it's of type string. So let's assume that I want to actually console log this and convert the my name to an uppercase. So in normal JavaScript, we would access the function from some form of lexical scope where function and uppercase is somewhere available inside of here. However, with imports and exports, we need to actually tell this formatter to export, and we want to import it into this main. So all we need to do to export is export the function. And you can see uppercase is not available. So what we can actually do is do import, and all we're going to do is import this uppercase from, and we're going to use the current, and we're going to import the formatter. So that has now found the module. Obviously, if we rename this, it's going to go red. So this is why TypeScript is also really nice, because if you spell anything wrong or reference a file, it will then tell you and we can correct it. And you can also click and it will then jump over to the file. So if I then close this and then click, it then opens that file for me. So there's some really nice features here in TypeScript, and hopefully this gives you a small introduction before we get started with actually writing some Angular code. Hopefully by now you've actually set up your project. However, we're going to go ahead and set up the project as well. Now the text editor that I'm using is called VS Code. Now you can go ahead and go to the previous video and actually see the download links for this. You can install the exact same text editor which I'm using. So at the moment, if you click on any of these Angular files, you'll see all these red underscores. So this is actually TypeScript telling us that these modules don't exist. So what we need to do to actually get Angular running is install these modules. So I can open up the terminal inside of VS Code here. All I'm going to do is simply run a yarn install. So what this does, and you'll see that this is much faster than an npm install, we'll go ahead and download our dependencies for installing our project. So now that that's finished, I can go ahead and run yarn start. And that's all you need to do. This will then take a few seconds to basically compile Angular. Now, while it's doing this, it will actually output it inside this vendor folder. So you can see that this has just been generated here. Angular is now available because we've now installed our dependencies, so the red underlines aren't there anymore. We can check again in the Angular module. So this is now running on localhost 4000. So if we go to the browser, we can go ahead and check this out. So in the browser, this is what you should be seeing. You should be seeing the word hello, and that's all you need to do. Every single video in this course is going to be using the same project base plate that you've just installed, and the source code will be fully available for each video that we run through. In your project boilerplate, you would have downloaded something like this. Now, you may have had a click around and seen a Sass file, component file, a module, and a main.typescript with some unknown names inside. So For this video, what we're actually going to do is focus on learning all of these fundamental basics that are inside this boilerplate so you can understand them before we move forward. Now, what I want you to actually do is highlight all of your code and simply delete it because we are going to start from scratch. So the first thing, now we've learned about imports and exports, is we need to actually import this thing called a component. Now the component is a decorator. A decorator is essentially just a function that annotates a specific function. So in this case, we will be using the component decorator against a TypeScript class to tell Angular some specific metadata like our template and the selector of our element, because when we create components, we create custom elements. So we'll continue with this and we'll do from, and we'll do apps angular/core. So this is now imported the component decorator. So underneath, what we can do is simply do export and then class. So we can obviously import and export from the same file. Now our component is actually the class name. So here we're going to export a class called app component, which is essentially a class that we looked at in one of the previous videos. Optionally, we can create a constructor inside of here, and we could optionally do something like this.groceries equals an array like we did in the initial video. However, because we're using TypeScript, we don't actually need to do this. So if I want to create something like this.groceries, I can actually just do groceries right on the actual component like this. And then we can say it's going to be a string array like we looked at in the first video. So for our component, all we're going to do is simply type the words title. Now title is going to be a string. Now we can optionally set the initial value up here, so we could do title Todd, but what we'll do is Ultimate Angular. If we didn't want to actually set the static property up here, we could in fact create a constructor, and inside of here we can then reference this.title and we can assign it the value of Ultimate Angular. So let's actually go ahead and remove this from here. So this is a nice way to actually develop, is actually declaring the type of the properties that you're using up here, and then we can simply use them inside of here. So now we've created a component, we can use this component that we've just imported from Angular. Now this goes above this export statement. So essentially the component is just a function. However, because it's a decorator, which is a TypeScript feature, all we need to do is simply prefix it with an @. So this is all we need to do to get our component actually registered with Angular to tell it that it is in fact a component. So essentially the component holds metadata for our particular component. In this case, it's the app component. So inside this decorator, we can create something called a selector. In the root project, we created app and then root. So the selector essentially creates the element in the HTML. Now, if we flick over to index.html, you can see we have app root. So all Angular projects have a base root component that then renders the entire application from. The next thing we need to do is actually assign a template to this particular component. There are two ways you can do this. We can use a template with an inline string. Now you can see here that I'm actually using backtick. So when I click over here, you can see that this is a backtick and not a normal string value here. So this is an ES6 feature that allows us to create multiple line strings with better readability. Now the first thing that we need to do is just inside of here, we can reference this title property because our component decorator essentially gets bound to this app component. All of these properties that we expose here, such as title, will then be available inside of here. So this is actually called interpolation, and we'll get onto this shortly in the video course. Now we've essentially understood what our component is, we've imported it from Angular's core. You can go onto the angular.io and check out the documentation to see where things actually come from, but essentially you'll be using component mostly. Component just decorates a particular class, the name of the component gets exported, and we'll work out in a minute how we actually register this with our module in the next video. So let's go ahead to the browser and actually check this out. So hopefully, if you've done that correctly, you should see the words Ultimate Angular in your browser. So now you've learned how to create your first Angular component using a TypeScript decorator. We've created a template in a string. However, we'll go back and show you two more things. You may have noticed that in the actual boilerplate itself, we had something called style and then URLs. Now this array contains a reference to our Sass file. So here we can do app.component.scss, which is our Sass file. So this will essentially allow us to style a particular component. So let's say, for instance, we do background red. So now we've added this background red to this app class. What we need to do is go back to our component, and all we can do here is just simply add class and then equals app. So once we've done this, we can then save this out and go to the browser to actually see this change occur. So you can see here that we have Ultimate Angular in the gray and the background of the component is red. We don't have to create a template inline like this. We can actually use something called a template URL. And similarly, we would use this approach. So what we would actually do is just simply reference a particular file. So we can do / and then app.component and then .html. So Angular will actually pull this in for us if we want to split the actual template into its own file. I personally prefer this syntax because it allows you to look at this and your template at the same time and understand what's happening without switching between files. So this is the approach that we'll be taking for this course. We'll be using a template inline, but we'll also be using a style URL when we need to. Next, we're going to use the ng module decorator to create our Angular module. Now, the boilerplate that you downloaded at the beginning comes with this app.module.ts, which has all these import statements from various parts of Angular, and we have this ng module decorator on something called an app module. So again, what I want you to do is delete all of the code and we'll go through it step by step. Now, the best way to think about a module is similarly to import statements and export statements in TypeScript or ES 2015. So first off, let's assume that we have our app component. So what we're going to do is import the app component, which is exported from here. So we have the app component, we're exporting it, and we now want to include it in our module. So what we'll do is then and because we're in the current directory, we can do app.component. So you can see that we do not have to put .ts on the end. We can simply just reference app.component. So now we've imported our component into the module, it's actually time to create the module. Now we do this by importing something called ng, and notice that the fact that the capital N and we have a module with an uppercase M. So we do this from the Angular core. So we're importing this module and we now need to go and tell this component that it needs to be part of the module. All our module is a container that contains all of our components and any dependencies that we need, such as services for HTTP requests. They all go inside a specific module. Now let's assume we're going to export a class called app module. So this essentially we can leave empty and we just need to decorate it with this ng module. So again, we can do @ng module. And now we've told Angular that this app module is now an ng module. So this is a special decorator. Now, because we've actually imported our app component, we need to obviously go and tell index.html to bootstrap this app component. So this is where we actually tell the module to bootstrap this particular component. So all we need to do is create a property and reference app component. Now these can typically live anywhere on your ng module definition, so I typically leave them at the bottom because the root module, which is our first module that instantiates the Angular app, is the only module that contains the bootstrap property. Now to actually register this app component in the module, we need to create something called declarations. Again, this is just an array. So all we need to do here is just simply pass in our app component. So here we're importing app component, we're registering it in the module, and we're telling the module to bootstrap our app component, which then corresponds to this app root here. So that's nice and simple so far. Now Angular is split up into multiple modules, so each piece of Angular, such as the forms or HTTP, lives inside a different module. The ng module and the component decorators which we've used live inside the core module, which is why we're importing Angular/core. However, because we're building a browser application, we actually want to import something called the browser module. So we can do import browser module and then from @Angular, and now we want to go ahead and choose platform browser. So we're now importing the browser module, and we also need something called a common module. So we'll do common module, and we'll also import this from @Angular, but this time it's actually coming from common. Now, once we get started into the templates and creating things such as directives, this is where the common module comes into play. So typically, these are the two modules that you'll need to include in your base ng module before you can get going. So let's go ahead and import the browser module and the common module into this existing ng module. So what we can simply do is do imports, and it's just going to be an array again. We can import the browser module, and we can say that we want the common module as well. So this is essentially all we need to get going with our Angular application. Now you understand the ng module and the reasons behind it. If we're not using a browser such as server-side rendering, we will import a different module. The common module gives us the directives that we'll need, which we'll come on to later in this course. And we're importing our base app component, which then gets used in the index.html. So at runtime, Angular will go and grab this ng module, find these particular imports, then we'll bootstrap our application based on our app component, and any further components live inside this declarations. So maybe we could extend our application. So in the future, we might want to add something like a dashboard component, and these things would live inside of here. So essentially, we just include a list of components. So we can do settings component, just to give you an idea of how we register particular components inside a module. So we'll remove these because we do not need them, and let's go back to the browser and make sure everything is working. So our application is still bootstrapped. We have the red background. So what we'll do is go back and actually remove this styles and continue through the course. So in the app CSS, all I'm going to do is simply delete this line and then save the file, and we'll just close this off. Now we've learned how to create a component and we've learned how to register that component in a module. We need to actually learn how to bootstrap that application. Now this is all done for you in the seed project. However, you need to understand the basics and be able to do it yourself should you need to. Now if you jump across into main.ts, you'll see this stuff here. Again, go ahead and delete the entire thing and we'll start from scratch. So the first thing that we want to do is import the module that we just created. So what we're going to do is import this app module, and we're going to import it from the current directory and /app. Now, because this is inside an app folder, this is why we're referencing this app directory. And all we're going to do is app.module. So this is now imported our app module. So now we need to tell Angular how to actually bootstrap this. There are specific ways that we can bootstrap an Angular application on the server, on the client, or we can pre-compile it, which is an advanced topic. If we want to compile in the browser, we have to use something called the platform browser dynamic, which you may have seen already. So what we can do is import and then platform browser dynamic. And then we get this from the @Angular, and we can just choose the platform browser dynamic. Now you can see here, it definitely says dynamic on the end. So this actually contains the client-side code that actually processes our templates, all of our bindings, and allows us to do dependency injection, which we'll come on to shortly. So essentially, we need this rather than the platform browser like we did before, because we need the dynamic version, which allows us to compile our app in the browser. So now that we've imported this, it's not a decorator, it is actually just a function. So we can just simply call this function, and we need to tell it what module to bootstrap. So we can just call this bootstrap module method and simply pass in our app module. So hopefully by now you can understand the flow of creating and bootstrapping an Angular application. So from the top, we have our app component. We register this as an app root, which gets placed in our index.html. Now to bootstrap this, we need to import the component, register it in a module. We need to tell the module to bootstrap the component. And then in our main TypeScript file, we can tell the compiler to bootstrap our application module. And that's all you need to know to get an Angular project running. We've already looked at interpolation, which are these curly braces here. Interpolation allows Angular to essentially bind specific properties from here. So we have app component.title, and then we simply bind it in the template. Now, this is actually called an expression. An expression doesn't have to be as simple as this. So in this video, we're going to look at how we can use a few different expressions with interpolation. So what we'll do is actually start off with some numbers. So what we'll do is create a first property called number1, and we'll give this a value of 1. We can say that this is a number if we like. Now we'll just duplicate this here, and then we'll assign it the value of 2. So we have properties number1 and number2. We don't have to set an initial value in the constructor because we're setting them up here. However, we can now go ahead and start using them in our template. So first off, let's actually look at number 1. So all we need to do is curly braces number 1, and then underneath what we'll do is look at number 2. So if we go across to the browser, we can go and see these rendered out. So here we have Ultima Angular and then 1 and 2. What we'll do to separate these is just wrap them in a div tag so that we can put them onto a new line. Now the interesting thing is because these are an expression, we can actually do JavaScript-like features. So here we've got number 1 plus number 2. So because these are actually number values inside our component, Angular will then know this and then actually do the maths underneath. So let's go and try this out in the browser. So you can see when we land in the browser, we see the number 3. Let's look at another example. We'll do another div, and inside of here, what we're going to do is use a ternary expression. So what we will do is we will just say is happy, and we'll do a smiley face if they are happy. Otherwise, we will do a sad face. Now, obviously, the is happy does not exist on the component, so we will go is happy and we will say it's a boolean, and we're just going to set an initial value of true. So when we go to the browser, we should see a smiley face in our template. And there you go, we have the number 3 from the numbers and we have the smiley face in the browser. So we can go back and change this to false, and we'll come back and have a look again. So we'll change this value to false, we'll save it out and go back to the browser. And now we have a sad face because obviously the user is unhappy. Now these are expressions that you can use in your Angular templates, and this just gives you an overview of the kind of expressions that we can use. With expressions, we can mix and match the types that we want to use. So for instance, title is a string, so I might want to put an exclamation mark after this. So here I'm actually concatenating both of the strings to add the exclamation. We'll save this out and go back to the browser. And you can see here that Angular has now parsed this out. So this gives you an overview of the interpolation expressions and how to use the different types of expressions that come into Angular. Property binding is how we can pass data from something like a component class into a template by binding it to a particular element. At the moment, all we've done is simply print out in the HTML the title Ultima Angular. However, what we actually want to do is probably bind something that the user can change, and this would include something like an input. Now, first, to understand what these curly braces are actually doing, they're actually called something called sugar syntax. Sugar syntax is an easier way of doing something that looks cleaner. So to demonstrate this, what we'll actually do is wrap this title in an h1 tag. Now the sugar syntax will take over and automatically put the title inside of the h1. All this is doing is basically setting the inner HTML or the text content for this particular element. So we can actually delete this entirely if we want to. Now in plain JavaScript, you may have accessed a particular DOM node and done element.innerHTML equals something. We have this same capability in Angular. So we can do inner HTML and then equals the title. Now, this won't actually work on its own because Angular needs to bind to a property. The way that we do this is using a square bracket notation around the property name that we want to bind to. And we do this because it indicates a one-way data flow syntax. So the data comes down from the class, binds to the template, and it looks at this property inner HTML, and it will set the inner HTML content. And just to show that this actually works, we'll actually create our original example underneath. So we'll do title, and we'll go and have a look at this in the browser. So here you can see that we have Ultimate Angular and Ultimate Angular. So by using property binding, Angular is actually looking up the JavaScript properties and binding to them specifically. Let's look at another example. One addition I've got here is I've added an image folder with a logo.svg inside. Now let's assume that we want to add an image tag. All we need to do here is create a source property, and we need to reference the actual image itself. So what we're going to call this one is logo. It's going to be a string, and we're going to give it a value. So it's going to be image/logo.svg because it's in the image folder. Now to bind this, we might think that you do something like this. However, we've just learned that we want to dynamically bind to the actual source. So underneath, Angular needs to know that you want to bind to the source property. If you think in plain JavaScript terms, this would be something like element.source equals logo.svg. This is essentially the equivalent of what we're doing here in the actual template. So when we go over to the browser, you can see here that we have this Ultimate Angular logo, and it's being bound via Angular. We want to do this because we can dynamically change this source of the logo if we want to. In a normal application, you might have a user input, and they may be able to press a button, and it may be able to change the source of an image. So using this square bracket notation allows us to bind to an image tag and inform Angular that we need to bind to the source property of the actual element. Another example we'll do is with an input. Now we'll give this one a type of text. How do we bind to this? If we want to set an initial value, we can say something like Todd. However, we're going to make this dynamic. So what we'll do here is create a name, and we'll say it's of type string, and we'll just give it a name of Todd. Now in the template, I can say value equals name, and again, we need to bind to the property of value. So if you think elements.value equals Todd, that's exactly what's happening underneath. So we're binding to the particular property on the element. Let's go and check this out in the browser. And here we have our element with the initial value of Todd that's been set. So this is called property binding, and it ties in nicely with the one-way data flow. When we start to build out our custom components during the duration of this course, this will actually make much more sense because we can actually create custom properties on our custom components. To demonstrate that this is actually one-way data flow, we can take this name value here that we're binding. If we use an expression, we can say name in the view, and you may be thinking as I type in the input itself that this value is going to be updated as well. So with one-way data flow, that's not the case. As we'll learn as we go through this course more about one-way data flow, when we come to creating our own custom components, this will make much more sense. So here we have the value of Todd. The value of Todd has been bound to the input. I can type my surname motto, and nothing here has been updated. This is using pure one-way data binding. And you can test this out on other elements such as a video element, an audio element, a div tag, a h1 tag, an input, a radio box, and you can see what properties that you can bind to. Anything that doesn't exist, Angular will throw an error in the console and say cannot bind to this specific property because it doesn't exist. In the previous video, we covered property binding, which is a square bracket notation, which allows us to bind to particular properties on an element. So let's say our input, we want to actually listen for changes and update this value here. So what we're going to do in this example is actually remove this piece of code, and we're going to learn how to use event binding. Now, event binding uses a slightly different syntax than property binding. So it's clear when you look at a component's template what's actually happening. So we can see here that we have a value that we're property binding to. However, when we want to listen to events, we use a slightly different syntax. Now, for the purposes of this video, I'm going to put these on new lines to make this a little bit clearer and easier to read. Now, an input has multiple events, as you probably well know. Events such as input, change, blur, focus, and a few others. So let's assume that we want to listen to a blur event. Instead of using square brackets, we use these normal brackets. So all we do inside of here is just type blur. Now you can see instantly by looking at this component that we have a binding here and an event here. So this syntax is really nice for instantly looking at what's happening in your templates. Now, when a blur event actually fires, we need to pass it a function. So inside of here, we can create a function perhaps called handle blur. Now, the interesting thing is we need to call this function and we can ask for this $event object. This handle blur function will actually throw an error if it doesn't exist on our component. So what we can do is create our function here. So we'll do handle blur. We'll expect the event back through the function arguments. For the sake of the video, what we're going to do is call it any. So any is a TypeScript type that just allows us to pass any kind of object through the function arguments instead of a specific event object. Now inside of here, what we're going to do is do console.log, and then we're going to do event. This event will actually give us the entire input itself. So when we go ahead and check this out in the browser, we'll actually see this working. So inside the browser, I'm actually going to leave the DevTools open so you can actually see this blur event occurring. So if I type motto, nothing happens. Once I click out of there, we then get this focus event. Now we can expand all of these, and you've probably seen some of these before. The one that we're interested in is this target property here. So you can see that when I hover over input, it's actually highlighting it in the DOM. So we can do target, and we can scroll down, and we can find the value property. Now the value is what we actually want to hook into. So you can see here that we have value with the new value inside of motto. So at this point, our handle blur function can then update the other listeners, for instance here, in our particular component. So what we're actually going to do here is go back inside of here, and once the blur event happens, we'll do this.name equals event.target.value. Now this will actually then take that value and assign it to this.name. So let's go and try this out in the browser. Again, I can type my surname, and then when we blur, we then have this updated value here, and obviously the event has then been logged out as well. So this gives you an example of event binding. So let's go ahead and create a few others. One typical event that we probably want to listen to on an input is the actual input event itself. So we're going to create handle input. This is also going to ask for the $event object. So inside handle input, we're pretty much going to do the same thing as before. So all we're going to do is update the value. So we're going to have the event, and it's going to be of type any. And we're going to say this.name equals event.target.value. So what will happen here is that when we actually start typing, because Angular is binding to this input and listening for an input event, it will then call our event handler on an input, which is when a user actually types. So each time we're going to get event.target back from the handle input event. So in the browser, we can go ahead, we can say Todd motto, and you can see as I type that the interpolated values below are actually being updated. So this gives you an example of what looks like two-way data binding. However, it's one-way data flow with an event being emitted from a particular component or an element, and it's telling our component that a change has occurred, and we're just updating a value of which Angular's change detection mechanism will go and update the other listeners, such as this one here. So when we make a change, all of what I've just explained is happening behind the scenes. One of the most common events that you'll probably want to listen to is a click event. So let's go ahead and create a button. As you can expect, we listen to a click event. And inside of here, we'll do change name. Now, we're not actually going to pass an event through, so we'll create this handle click, but we'll just simply call it. So when we go down to our component, we can add this property. It doesn't have any function arguments, and we can say this.name equals motto. So whenever we click, it's going to run this function, it's going to update to motto, and as the one-way data flow is happening and the data binding here, both of these are then going to receive an update from this component class down into the template. We can start typing as usual. Now, if I click change name, you'll see that it's just changed both of these. So this gives you an example of the one-way data flow and the events that are being tied in together when we're creating Angular applications. In the previous video, we looked at an event binding, such as input or blur and a click event. Now, you may be thinking that event.target might not be a great way of doing things. So what we're actually going to do later on in this course is look at Angular Forms. However, what we're going to do just for this example is import something called the Forms module, just to show you a Angular directive that will allow us to essentially do something called two-way data binding. And I want to demonstrate this earlier on, just to give you an idea that you can use one-way data binding and two-way data binding. Two-way data binding might be okay if you've got a local component. However, when you want to emit a change, you should always use one-way data flow and emit that change with an event listener. So to include this Forms module, we can just simply go down here and import the Forms module. We can close this off because we don't need it. So now we've got the Forms module available to us in Angular. So let's go ahead, and what we'll actually do is change this value binding, because we're actually binding directly to this value property. Instead of this, what we can do is use something called an ng model. Now, ng model comes in various forms. So what we can do is do ng model equals name. So after we've added the ng model, we can essentially get rid of this value. For now, we'll keep the input and the blur events, and we'll go and check this out in the browser just to see what's happening. So when we land in the browser, we can start typing. The ng model that we've just included from the Forms module is actually talking to the input itself. So it's essentially doing this square brackets value that we looked at before for you automatically. So we're demonstrating this because we can now go back and implement the ng model change. So inside of here, what we'll do is get rid of the blur event, and instead of handle input, we'll just call this handle change. What we'll do first is go down and change the handle input. We'll get rid of the handle blur, and what we'll also do is get rid of the event.target.value. And we'll just rename this to value, and the value that it's going to give us is actually a string. So when the handle change function gets called, it's going to pass us an event string. Now the way that we can do this is using ng model change. So you can see here that we're binding using ng model, but we're listening to a change event because this is an event binding. So when something changes, handle change will get called, the event is given to us. So let's save this out and go back to the browser. And again, we can go and start typing, and you can see that this two-way data binding is essentially happening. So ng model is taking a property binding, ng model change is taking an event binding. Now, the reason we're demoing this is to demonstrate the two-way data binding. This is technically one-way data binding, which listens to a change via an event, and then we rebind it. So we can actually use the ng model to create an implicit two-way data binding. So what we can do is leave this example with the handle change event and the handle change function here. However, we don't need this line of code if we want to implement two-way data binding with ng model. All we need to do is simply wrap it in these braces. So at first this might look very strange. We have a property binding, and inside of that we're listening to an event binding. So under the hood, Angular is essentially going to run all of this code for you. It's going to run some form of handle change, and then it's going to update the name internally. So when we go back to the browser, we can actually see this happening. So when we go back to the browser, I can focus on the first input. Now this input is using the handle change function, whereas this input is using the two-way data binding syntax. So it doesn't matter which I update, the two-way data binding is happening on this input. The one-way data binding is happening on this put. However, we are responding to the ng model change event. So using the square bracket notation essentially combines the two to make the syntax even shorter for us. So that's an overview of how to do two-way data binding. Ideally, you would do this for an input only or a text area, for example, rather than just components itself, because it's much easier to manage your data and the state of a component and a template by using one-way data flow and event binding. Now we're going to learn about something called a template ref or template reference. Now in the previous video we included our Forms module and included it in the ng module, so we're actually going to remove these because we don't need them anymore, and we'll jump back to our app component. Now obviously because we've deleted the modules, these will all break, so I'm going to show you another way that we can actually handle these changes using a template ref variable. We're going to keep this button, we're going to change it slightly, but we're also going to get rid of all this ng model stuff. So if we go ahead and quickly normalize this input, and we'll remove this one here, and we'll just change this text inside of here to get value. We'll keep the handle click as handle click. However, what we're going to do is pass in a value from our input using a template ref. And we'll remove the handle change function. So everything has gone back to its original state. So what we've covered so far are things like value and the ng model and these kind of bindings. Now there's something called a template ref variable, which essentially allows us to create a reference to a particular DOM node which is accessible anywhere in our template. Now these are really, really handy. So let's assume I want to create a hash username. This tells Angular that I want to set up a ref. Now this doesn't mean anything just yet. However, if we pass the username.value into here, you might start to get an idea of what's actually happening. So what we're going to do is get this through the function arguments as a string, and we're simply going to do console log and then the value. So let's go and try this out in the browser. So what we can do is essentially type something. So we'll type my name in again. We've got no blur or focus events or input events. Now the fact that we're actually using a template ref will keep a reference to the underlying DOM node. So when we pass it into our click function and press get value, you see that we've got this value passed back called top motto. I can put an S on the end, and you can see that each time we click, we're getting that new value. Now a template ref gives us an access to the particular DOM element. It essentially exports the properties so we can access it anywhere in our template using that hash variable.